చెప్పండి సార్.
Madam, one student joined the session.
ఓకే.
We can start.
ఓకే సార్.
Thank you.
Good evening, everyone. So today is the second section for quantitative techniques. Now we will start the section. So in yesterday's class, we discussed about uh, measure of central tendency and measure of variance. And in today's class, we will discuss about screwness and probability, theories of probability, distribution of probability. So screwness. So in last class, we already discussed about screwness. So what is screwness? Screwness is lack of symmetric feature. So symmetry means when mean, median, and mode, three factors are equal at a particular point. That particular point is called symmetric. Suppose if any dimension, that particular symmetric nature is failed, then that is called screwness. Sorry, it's not, there is a problem, technical problem actually. Okay. So screwness refers to lack of symmetric in distribution. So how you can measure the screwness means mean minus mode by standard deviation. So you just see these three diagrams, graphs. First one, symmetric. Symmetric means when that particular point has mean, median, and mode are in equal range, then that particular point is called symmetric nature. Okay, so that is shown in the first diagram. And in second diagram, negative screwness distribution. That means this particular screwness is negative. Okay, why it is negative means mean is less than median and median is less than mode. That's why it is shifted to the that means right side. So if that particular diagram is shifted to right side, then sorry, left side, then that type of diagram is called the negative screw distribution. And positive screw distribution, that is shown in the third diagram. That means mean is greater than median and median is greater than mode. In that particular situation, positive screw distribution will appears. Okay, so here that particular curve will bend towards positive. That means the right side. Okay, if that particular curve is bent right side, then that is called positive screw distribution. So now in this particular section we will discuss how to calculate the screwedness. Okay, so this is the problem given, and you have to find the screwness. Okay, so profits are given in thousands and number of companies are given. Okay, since the given distribution is not open ended and also the mode can be determined, it is appropriate to apply Curl Pearson formula for a given problem. So through this particular Curl Pearson formula, screwness can be calculated with this particular formula, mean minus mode by standard deviation. Okay, so here we have class intervals 10 to 12, 12 to 14, 14 to 16, 16 to 18, 18 to 20, 20 to 22, and 22 to 24. So these are the class intervals and they are already given frequency. So 7, 15, 18, 20, 25, 10, and 5. So these are the frequencies. Now we have to calculate on this particular data. Okay, so first we have to calculate the midpoints. So midpoints are represented with capital X. Okay, so 10 to 12, the midpoint is 11. 12 to 14, 13. 14 to 16, the midpoint is 15. Okay, And in 16 to 7, 16 to 18, midpoint 17, 18 to 20, 19, 20 to 22, midpoint is 21, 22 to 24, midpoint is 23. And in next column, we are entering the F values. So F values are already given in the problem, number of companies. So that represents the frequency F. So 7, 15, 18, 20, 25, 10 and 5. Now we have to calculate D. So for calculating D, x minus a by 2. So how to calculate a, we already know. So the midpoint, in the midpoint, whatever value is at the center of that particular distribution, that particular midpoint is taken as a auxiliary point. Okay, so this is the odd distribution, odd number of distribution. That means 1, 2, 3, 4, 5, 6, 7. So 7 observations are given. Okay, so this is a odd distribution. In odd distribution, the midpoint, that means the central midpoint is the auxiliary point. That means central midpoint is 16 to 18 class interval. Okay, so 16 to 18 class interval is the fourth position in seven observations. So that is the midpoint or middle of that particular distribution. So in that particular 16 to 18 classification, the middle point is 17. So 17 is taken as a. Okay, now D, calculate D is equal to x minus a by 2. So x values are midpoint values, and 17 is the auxiliary point which is calculated, that means which is derived from the middle points, and by 2. 2 means I, that means class interval. So 10 to 2, the difference is 2. That's why I is equal to 2. So D is equal to x minus 17 by 2. Now calculate the D value for each and every observation. Okay, so for first observation, 11 minus 17. 11 minus 17 minus 6 by 2 minus 3. Next 13 minus 17. So 13 minus 17 minus 4 by 2 minus 2. Okay, 15 minus 17 minus 2 by 2 minus 1. Next, 17 minus 17, 0. 19 minus 17, 2. 2 by 2 plus 1. 21 minus 17, 4. 4 by 2, 2. 23 minus 17, 6. 6 by 2, 3. Okay. So these are the D values. Once you get the D values, then you have to calculate the FD. FD means frequency into D value. Okay, so 7 into minus 3, minus 21, 15 into minus 2, that minus 30, 18 into minus 1, minus 18, 20 into 0, 0. So like that you have to calculate the FD values. Then you have to calculate F into D square values. Why we have to calculate all these values means because we have to calculate the mean value and mode value. So we know the procedure for calculating mean and mode. Okay, so for mean we have to calculate the formula, that means with a plus sigma fd by n into I. So here we have to mention the sigma fd value. So that's why we are calculating fd and fd square. Okay, so in another column we have to calculate f into d square. So f7 d square 3 square minus 3 square, that means 9. 7 into 9 63. 15 into 2 minus 2 square, that means 15 into 4 60. 18 into minus 1 square, that means 18 into 1 18. So like that you have to calculate fd square. Okay, once you calculate all these table, that means you completed all these table values, then you have to sum up sigma fd square, and n will be comes from frequency. So if you sum up all the frequency values, 7 plus 15 plus 18 plus 20 plus 25 plus 10 plus 5, so total observations is 100. So n is equal to 100. Now calculate x bar, that means mean, is equal to a plus sigma fd by n into I. So a means auxiliary point which is derived at the starting of the problem, 17. 17 minus sigma fd. Sigma fd is derived from the table, minus 9. Okay, so minus 9 by n, 100 into I means class interval 2. Okay, so 17 minus 9 by 100 into 2. So you will get 16.82. So that is the mean value for this problem. And mode for calculating mode, the formula is x L plus d1 by d1 plus d2 into I. So L means, again you have to know the class intervals. Okay, so in which class interval this particular f is high. Okay, so you just concentrate on f values. Okay, f values 7, 15, 18, 20, 25, 10 and 5. So which has the highest number? 25. 25 is the highest number, so that particular class is the uh, lower level. That means L value, you will derive L value from that particular class. So 25 is corresponds to the 18 to 20 class interval. So here 18 is the L value. Okay, and you have to find out d1 by, that means d1 divided by d1 plus d2 into I. So you will get 5 by 5 plus 15 into 2, so 18.5. So next you have to calculate SD, sigma, that means standard deviation, sigma. For sigma, the rule is, the formula is root over sigma fd square by n minus sigma fd by n into I. So already we calculated sigma fd square 251 by n means 100 minus sigma fd is minus 9 by 100 into 2 with all over root. Okay, so if you calculate that formula, then you will get sigma is equal to 3.1634. Okay, so mention the values on screwness formula. So for calculating screwness, the formula is mean minus mode by standard deviation. So the mean value is 16.82 minus mode 18.5 by standard deviation 3.1634. So you will get this screwness minus 0.5310. That means for this particular problem, negative screwness distribution is there. Okay, that's why the screwness value is in negative. Okay, so like this you have to calculate the screwness. The next topic is probability. So how what is probability and why you have to use this particular probability? The probability of a given event is expressed of likelihood or chances of occurring of an event. Okay, actually for calculating probability, why we are calculating this particular probability in business means because business is uncertain. Okay, we have to deal some uncertain situations. Okay, so for dealing uncertain situations, first you have to forecast something. Okay, without forecasting we can't plan properly how to deal that particular situations, right? So for forecasting or predicting that particular situations, you can use this particular probability techniques. Okay, so in that particular situation we are using this particular probability situations in the business. So now what is the definition of probability? The probability of a given event is an expression of likelihood or chances of occurrence of an event. That means probability is chance of occurring. It is not totally happens. We can estimate. That means there is a chance of occurrence of that particular situation. So we are calculating the chance. Okay. Another definition for probability is the ratio of number of favorable cases to the number of equally likely cases. That means when you do an experiment, then you have to know what are the favorable cases in that particular experiment and how many times you are doing that particular experiment. Okay, if you take the ratio, then you can get the probability for that particular situation. So that is called ratio of number of favorable cases to the total number of equally likely cases. For example, for this particular definition, there is a example. Suppose if you toss a coin. Okay, so for getting a tail or for getting a head, you have equal number of results. That means once you toss a coin, there is equal chances of getting head or tail. That means 1 by 2. Suppose if you want to get the head, there is a chance of 1 by 2. For getting tail, again you have 1 by 2, because here you are tossing that particular coin for only one time. The result is also once, either that is head or tail. That's why the favorable cases is only one. For head there is a favorable case only one. Okay, for tail also there is a favorable case is only one. But how many total likely cases? Two, because you can get tail or you can get head. So that's why 1 by 2. Okay, so this is the example of second definition. And what is experiment? In probability, what is experiment means? It is described as an act which can be repeatedly under some given condition. That means we are repeating that particular act in a certain conditions. That type of act is called experiment. That means suppose if you are tossing a coin, then the condition is it can't be a bias. Okay, that means you are expecting that coin will be that means that coin will be placed in a right position, right? So by seeing that type of situation, that means by knowing that type of condition or placing that type of condition, you are doing that particular act. Suppose that particular toss is not in the right position, automatically you can't expect the results, right? Suppose that particular coin is biased, okay, so you can't get head or you can't get the tail. So that is biased situation. But here you want unbiased situation. That means the coin must be placed in a right position, whether that occurs head or tail. Okay, so that is the condition for that particular act. Okay, so that is called experiment. Experiment is nothing but an act which will be repeated under a particular condition. Okay, and next one is random experiment. So what is random experiment? Actually, before that means before doing this particular experiment, you can't expect the result with certainty. That type of experiments are called random experiments. Okay, the experiment whose outcome cannot be predicted with certainty before the experiment is run. Okay, so before doing that particular experiment, you can't expect the outcome of that particular act or experiment. That is random experiment. As I already told you, if you toss a coin, you can't expect whether it will come head or tail. So that is random experiment. Okay, you can't certainly you can you can't certainly say that will be head or that will be tail, right? So that is random. And compound experiments. So compound experiment is one can form a new compound experiment by performing an experiments in a sequence, and each must be independent with every one another. That means you have to do this particular act n number of times. That means repeatedly you have to do that particular act, but each act must be independent. That means each experiment must be independent with each other. Suppose if you have a 10 balls in a particular place, okay, with replacement you are conducting 3 experiments. Okay, so that is called independent with each other. And next one, event. What is event? Event is a set of outcomes of the experiment. That means we are doing the act, but when that particular act gives some output or outcome, that is called event. Okay, that means you are tossing a coin. When that particular result will be a head, then the event is head. That means for this experiment, you are getting the event of head. Okay, so that is called event. That means outcome of that particular experiment is called event. And what is compound event? A compound event means the joint occurrence of two or more simple events. Okay, that means actually when you toss a coin and you that means you are tossing a two coins simultaneously. You are not tossing a single coin, you are tossing a two coins simultaneously, and you are expecting at least one head in this particular situation. Okay, so that means maybe one coin will, that means when tossing one coin you will get the head, or in some situation you will get two coins as a head. Okay, so that type of events are called compound events. That means mixture. Two or more simple events are mixed in that particular outcome. That type of outcome is called compound outcome. Okay, and what is mutual exclusive events? So mutually exclusive events means two events are said to be mutually exclusive when both cannot happen simultaneously in a single trial. So when you do an experiment, these particular two results cannot be happen in that particular experiment. Okay, so when you toss a coin, you can't expect in that particular experiment you both head and tail will occur. Okay, you can't expect both results, right? You can expect any one result, either head or tail. You can't expect both results will happen at by tossing a single coin, because these both results are mutually exclusive. That means when head occurs, tail will not happen in that particular situation. Okay, and tail occurs, head will not appear, right? So these type of situations are called mutually exclusive events. That means the both situations never happen in a single experiment. And independent events, so independent events means two or more events are said to be independent when the outcome of one does not affect or is not affected by others. That means when you are conducting these particular events, one that means series of experiments, when you are conducting series of experiments, the event, that means the outcome of that particular series. Okay, the outcome of one experiment will not affect the outcome of other experiment. That type of events are called independent events. That means suppose you have a bunch of balls in a particular bag, and you want a black ball in a first trial, and you want blue ball in another trial. Okay, suppose if you are not replacing that particular ball, first ball, suppose if you taken one ball from that particular pack of balls, that is one experiment, whether that is black or blue. Okay, you are taken that particular ball from that particular pack of balls, and you are not replacing that particular ball for the next trial. And in next trial, you have only 9 balls in that particular pack of balls, right? So that means this particular incident, first experiment will not affect the result of the second experiment, right? So that type of situations are that type of outcomes are called independent events. That means they never impact the other experiments outcome. Okay, and dependent events means the one that means outcome of one experiment will affect the outcome of other experiment in that particular series. Okay, that means you are conducting 10 trials. In that particular 10 trials, first experiment result will affect the second experiment result, and second experiment result will affect the fourth experiment result. Like that, they are affecting the outcome of the other experiments. So that type of events are called dependent events. Okay, that means if a card of that means the pack of cards are there, and you are not replacing that particular card once you have picked from that particular card. Okay, that means they are affecting that particular, that means they are depending on that particular outcome. Okay, first outcome, that means first experiment outcome will affect the second experiment's outcome. That type of events are called dependent events. And first we will discuss about additional theorem. Okay, so what is additional theorem? Actually, additional theorem, if you have two events, A and B, and these are mutually exclusive, that means when A happens, B will not be happen, B happens, A will not be happen. Okay, so these two events are mutually exclusive, and the probability of occurrence of either A or B is the sum of individual properties of A and B. Okay, if you want the probability of occurrence of A or B, then the add addition of the individual properties of this particular two events is called the additional theorem. So p of a union b is equal to p of a plus p of b. Here p of a is the probability of event a occurrence, and p of b is probability of occurrence of b event. Okay, so sum of all two individual probability events in a mutually exclusive events. Okay, so what is the problem for this particular theorem? What is the problem means, suppose you just see the example. One card is drawn from the standard pack of 52 cards. What is the probability that it is either king or a queen? Okay, so here king and queen are mutually exclusive events. That means for a single card, you can't get king or queen, right? You can get king, either you can get king or you can get a queen. So these two events are mutually exclusive. Okay, so this for this particular situation, you can use the addition theorem. Okay, so there are four kings and four queens in a pack of cards, right? So the probability of one card drawn, which is a king. So what is the probability of getting the king card from the pack of 52 cards means, because kings are only four cards, 4 by 52. Okay, and queen card, for getting the probability of queen card from the pack of 52 cards, again 4 by 52. Now, what is the probability of getting king or queen? 4 by 52 for king and 4 by 52 for queen. Total is 8 by 52. That means 2 by 13. So this is called additional theorem. Because these two events are mutually exclusive, you can apply additional theorem in this particular situation. Okay, when events are not mutually exclusive, suppose when events are not mutually exclusive, even though you want to apply additional theorem in that particular situation, then what is the formula? Okay, P of A union B is equal to P of A plus P of B minus P of A intersection B. Or suppose if you have a three events, P of A union P of A union B union C is equal to P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of A intersection C plus P of A intersection B intersection C. But we don't get three events at the same time. We just focus on first formula. P of A union B is equal to P of A plus P of B minus P of A intersection B. When the events are not mutually exclusive, then only you have to use this particular formula in the additional theorem. Okay, so for example, the problem is, what is the probability of drawing either king or a heart from a pack of cards? Because king and heart, these are not a mutually exclusive events, because in a card you can get king and queen in a single card, in a same card, right? So that's why these particular two events, king and heart, is not a mutually exclusive events. In this particular situation, you have to use additional theorem. Then you have to use this particular formula. P of A union B is equal to P of A plus P of B minus P of A intersection B. Okay, so here A means king and B means heart. So P of king or heart is equal to P of king plus P of heart minus P of king and heart. Okay, so for king, what is the probability of occurrence of king from a pack of 52 cards means 4 by 52. And heart, okay, that means heart symbol will appear in 13 cards from the pack of 52 cards, right? So that's why the probability of occurrence of heart in a particular pack of cards is 13 by 52 minus P of a king and queen, sorry, king and heart. That means for a single card only you can get king as well as heart. So the occurrence of king and heart in a single card is 1 by 52. Okay, so 4 by 52 plus 13 by 52 minus 1 by 52. That means 16 by 52, 4 by 13. So that is the answer for this particular problem, 4 by 13. So this is for not mutually exclusive events. So that is the additional theorem. Next problem is multiplication theorem. So what is the multiplication theorem in probability? If two events A and B are independent, that means independent means these particular events are independent with each other. That means the outcome of the events is independent, they are not affecting with each other. Okay, so that type of A and B are independent, the probability that they both will occur is equal to the product of their individual probabilities. Okay, so when the probability of occurrence of both is equal to product means multiplication of individual products, individual probabilities. So P of A intersection B. A and B means A intersection B is equal to P of A into P of B. For addition theorem, we are using that means union, A union B. For multiplication, we are using A intersection, that means and A intersection B. So P of A intersection or P of A and B is equal to P of A into P of B. So that is the formula for multiplication theorem. Okay, so you just see the example. Okay, a man wants to marry a girl having white complexion. The probability of getting such girl is 1 in 20. Okay, and handsome dowry, the probability of getting this is 1 in 50. And westernized manner, the probability of getting this type of woman is 1 in 100. Find the probability of his getting married in such a girl when the positions of three attributes is independent. So three attributes are independent, that means they are not affecting with each other. Okay, so if that particular attributes are independent and that attributes must be possessed by that particular girl, so what is the occurrence of this particular situation in that particular man's life? So you have to calculate the occurrence of the situations, okay, attributes. So probability of girl with white complexion, as we already discussed, that is given 1 in 20. So 1 by 20. So individual probabilities, you have to calculate individual probabilities. So P of A here, white complexion, probability of occurrence of white complexion. So that is P of A. Okay, 1 by 20, 0.05. And probability of girl with handsome dowry. So that is P of B. So 1 by 50. 0.02. And another one, P of C. P of C is probability of girl with a westernized manner. Okay, so that is 1 by 100. That means 0.01. And these attributes are independent. That's why we are applying multiplication theorem. Suppose if these particular attributes are mutually exclusive, then you are using the additional theorem. But these are not mutually exclusive. Why? Because maybe white complexion is there and that particular girl has a westernized manner. You can expect both attributes in a single person, right? So you can't say that particular person, that particular two attributes are impossible in a single person. Okay, that's why these may be independent but these are not mutually exclusive. So that's why we are using multiplication theorem in this particular problem. Okay, so now, because these events are independent, the probability of simultaneous occurrence of all the qualities is P of A into P of B into P of C. That means 1 by 20 into 1 by 50 into 1 by 100 is equal to 0.00001. So that is the answer for this particular problem. And additional problem is over and multiplication theorem is over. Now the next one is conditional probability. This is also one of the theory in probabilities. So conditional probability, what is the conditional probability when we use this particular conditional probability? So conditional probability is also a multiplication theorem. It is also multiplication theorem, but here the events are dependent. In multiplication theorem the events are independent, but here these particular events are dependent. Okay, in dependent events we are using conditional probability. So you just see the particular explanation. The multiplication theorem explained above is not applicable in case of dependent events, because problem is related with independent events, right? So two events A and B are said to be dependent events when B can occur only when A is known to have occurred. That means when B can happen when A already happened. Okay, B happened, occurred, then this particular B can be happened. That means these two events are dependent. For this type of situations we are using the conditional probability. Okay, so how we can do this particular thing means, this particular probability attached to such an event is called conditional probability. That means when A and B are events are independent events, then we are applying the conditional probability. How you denote this particular conditional probability means P of A by B. So P of A by B means probability of A given that B has occurred. That means when the that means B already happened. Okay, B is already happened. You are taking the probability of A. Okay, that so what is the impact of B on A? You are you are estimating, or you are guessing the probability of A occurrence when B is already happened. That is called P of A by B. That means probability of A given that B has already occurred. Okay, and if two events A and B are dependent, then the conditional probability of B given A. Now, B given A, the probability of B given A. That means A is already happened and you are estimating the probability of B. That means what is the denotation? That means denote for this particular situation P of B by A. P of B by A means A is already happened. You are expecting the probability of B. Okay, so P of B by A is equal to P of A intersection B by P of A. So that is the formula for P of B by A. And probability A given B is. That means the probability of A when B is already happened. That is denoted with P of A by B. Because in denomination, whatever element is there, that particular element is already happened. Okay, so P of A by B is equal to P of A intersection B by P of B. Because P of B is already occurred. That's why you are taking P of B. Okay, and general rule, the multiplication is modified in terms of conditional probability. Then how you will calculate means P of A intersection B, or P of A and B is equal to, in the above problem you are getting the denomination value into right side. Okay, so here in above problem P of A by B is equal to P of A intersection B by P of B. Now P of A intersection B is equal to, you are getting the denominated term into right side. Okay, so P of A intersection B is equal to P of A by B into P of B. So that is the formula for P of A and B. P of A and B is equal to P of B into P of A by B. And okay, and suppose if you have a three events A, B, C, then P of A, B, C is equal to P of A into P of B by A, because A is already occurred. That's why P of A. And now the A is occurred. What is the probability of B when A occurred, and that A occurred effect is on that particular probability value. Okay, that's why P of B by A into P of C by AB. Okay, in the third situation, B is already happened. A is happened and B is already happened. That's why you are taking P of C by AB. Okay, so that is the formula for P of A, B, C. So P of A into P of B by A into P of C by AB. Okay, so the problem. A bag contains 5 white balls and 3 black balls. 2 balls are drawn at random, one after the other without replacement. Okay, so without replacement means you are going with dependent variables. Okay, so find the probability that both balls drawn are black. Okay, so what is the probability that the both balls, okay, what are black? Because now we have 5 white balls and 3 black balls. Okay, so the probability of drawing black ball from the first attempt, because here we attempted two times, right? So first attempt, what is the probability of drawing black ball in the first attempt means black balls. How many black balls are there? 3 black balls. 3 by total balls. 5 white balls plus 3 black balls. So 3 plus 5, 8. So 3 by 8. And now in second attempt, because this particular replacement is not occurred. Okay, so the first experiment is over. You have already taken one ball from the 8 balls. Now you are not replacing that particular ball, so now we have only 7 balls. Okay, because it is a dependent event. Okay, because that is dependent on the first experiment, because that first experiment the ball is not replaced. Now we have only 7 balls, so this result is dependent on the first experiment. So that's why these are the dependent events. Okay, now the probability of drawing black ball, given that the first ball drawn is black. Okay, so the first ball is drawn black, and now what is the probability of drawing the second attempt as a black ball? Okay, that means P of B by A. A means first attempt. What is the probability of drawing the black ball at the first attempt is the P of A. Now, after taking first attempt as a black ball, what is the probability of taking the black ball in the second attempt also? The probability of drawing black ball, given that first ball drawn is also black. So P of B by A is equal to, okay, now black balls are only 2, because already in first attempt one is black ball. Now from the 3 balls only 2 balls are there in the black color, right? So 2 by, in total balls also 5 white balls are there and 2 black balls are there. So 5 plus 2, 7. So 2 by 7. So in second attempt you will get 2 by 7. So probability that both balls drawn are black is equal to P of A into P of B by A is equal to 3 by 8 into 2 by 7 is equal to 3 by 28. So this is called conditional probability. Conditional probability is applied only for dependent events, not for independent events. Okay. And what is Bayes theorem? And it is very very important theorem. What is the Bayes theorem? And Bayes theorem is also derived from the conditional theorem. Okay, so if it states that A and B are two mutually exclusive and collectively exhausted events. So mutually exclusive events. So mutually exclusive event means when A occurs, B will not be occurred, and B occurs, A will not occur. So that type of events are called mutually exclusive events. And collectively exhaustive events, that means exhaustive events means they have their own distribution. Okay, so and C is another event defined in the context of the same experiment. That means here C is another event which will affect this particular A and B. Okay, so that is derived from the same experiment. Then given the value of P of A, P of B, P of C by A and P of C by B, because here C is the condition, okay, which will affect the mutually exclusive events A and B. That's why you have to consider P of A, P of B and P of C by A, because A is already happened. What is the probability of C occurrence when A already happened? That why P of C by A and P of C by B. Okay, now the formula. Okay, here in this particular situation we are calculating P of A by C. That means when C is that means that condition, C condition happened in that particular experiment, what is the probability of A occurrence, or what is the probability of A happens when C is already existed. Okay, so P of A by C is equal to P of C by A into P of A by P of C by A into P of A plus P of C by B into P of B. It is not P of A, it is a P of B. Okay, and next one, for B also, you have to calculate this particular same situation. P of B by C is equal to P of C by B into P of B by P of C by B into P of B plus P of C by A into P of A. Okay. So you just see this example. Through this example, you can understand very effectively. So consider the case of manufacturer who is using a particular machine for producing a product. Okay, they want to produce a product. For that, they are using a particular machine. Okay, and the early data, he has estimated the chances of machine being set correctly or incorrectly. Here A and B means, A means setting correctly that machine, that is P of A, and event B means setting incorrectly that machine, you are setting that particular machine incorrectly, that is B. Okay, because when you are setting that particular machine correctly, you can't expect that particular machine will be incorrect, right? So that's why correcting and incorrecting are mutually exclusive. So you can apply this particular Bayes theorem for this particular problem. Okay, so here, set correctly or incorrectly are 0.6 and 0.4 respectively. Thus, we have two mutually exclusive and collectively exhaustive events. So, A means the setup is correct. B means the setup is incorrect. Okay. And now P of A. P of A is already given 0.6 and P of B is given 0.4. Okay. Now from the past data, the manufacturer has estimated that when the machine is set correctly, it produces 10% defective items. Here C means defective items. Okay, so we already discussed in the Bayes theorem, you have A and B exclusive events. C is another thing, another condition happens in that particular experiment, right? So here in this particular situation, in this particular problem, A and B are machine is correct and machine is incorrectly set. C means defective items. When you are producing some products in that particular corrective mission, what is the chance of getting the defective items? So that is called P of C by A. Okay. Suppose if that particular machine is incorrectly set, what is the probability of getting defective items in that particular situation? That is P of B by C. Okay. So here now we have to determine. Okay. So the manufacturer has estimated that when a machine is set correctly, it produces 10 defective items. Otherwise, that means when the machine is incorrectly set, then it produces 60% of defective items. Okay, so here we have P of A. P of A is already given in the problem 0.6 and P of B is also given 0.4. Now, this particular 10% defective. Okay, so 10% defective items when it is set correctly, that means P of C by A is equal to 10% means 0.1, 10 by 100, 0.1. And P of defective items when it is incorrectly set. Incorrectly set means B. So P of C by B is equal to 60%. It is given in the problem, right? 60% is given when it produces 60% defective. Okay, so 60% means 60 by 100, so 0.6. So we have P of A, P of B, P of C by A, P of C by B. Now you have to calculate P of A into C. Okay, for calculating P of A into C, the formula is P of C by A into P of A. And for calculating p of b and c, b intersection c, you have formula of p of c by b into p of b. Okay, so for calculating p of c, okay, if you want to know how many defective items are there in this particular situation, then you have to consider both correctly set, that means if you set that particular machine correctly and if you set that particular machine incorrectly, then also you have to consider two situations. Okay, so what are the defective items in that particular both situations, that is p of c. Okay, so P of C is equal to P of C by A into P of A plus P of C by B into P of B. Okay, now you have to calculate. We are interested in finding the probability that setup was correct given that defective pieces are coming out. Okay, that means the machine is set in a correct way, but the defectives are coming out. So we are calculating P of A by C. Okay, so P of A by C is equal to P of A into C by P of C. So P of A into C already we derived from the formula. P of A into C means P of C by A into P of A. By P of C means you have to consider both the situations. P of C by A into P of A plus P of C by B into P of B. Okay, now apply the values. So P of C by A means 0.1 into P of A. P of A means in the above problem we discussed 0.6. Okay. So 0.1 into 0.6 by, so P of C by C by A means again 0.1 into P of A means 0.6 plus P of C by B. So P of C by B means 0.6, 60% defective. So 0.6 into P of B. P of B is given in the problem 0.4. Okay, 0.4 is equal to, okay, when you calculate this particular thing, then you will get the value of 0.2. That means P of A by C. That means when that particular machine was correctly set, so defective items are producing, how many defective items will be produced? Okay, so P of A by C is equal to 0.2. That means for every 100 products, you can expect 20% of products. Okay, so this is called conditional, this is called Bayes theorem, and it is very, very important theorem in the probabilities. Now, the next topic is probability distribution. So till now we discussed about theories, probability theories. So additional theory, multiplication theory, conditional probability and Bayes theorem. So these are the theories. Now we are discussing about probability distributions. Actually, there are two types of probability distributions. One is discrete probability distribution. Second one is continuous probability distribution. So what is discrete probability distribution? Suppose if you are, that means if that particular probability distribution has a specific integers, you can express that particular probability distribution in a specific integers, then it is called distribute probability distribution. That means suppose if you want to know children in a particular family or number of people in a particular colony. Okay, so you can know the exact number, right? So that type of probability distribution is called discrete probability distribution. And continuous probability distribution means here you can't express that particular thing, particular probability distribution in a single number. Okay, so that means continuous, it is a continuous process. Okay, suppose height of the students in a particular class, or weight of the students in a particular class, marks of a student in a particular class, it is a continuous distribution. You can't specifically say this particular point is the probability of that particular situation, right? You can't express that particular thing in an integer. Okay, so that is continuous probability distribution. In discrete probability distribution, again, that is classified into two types: binomial distribution and Poisson's distribution. And continuous probability distribution is classified into normal distribution and exponential distribution. So binomial distribution, first discuss about binomial distribution. Actually, binomial distribution mainly discusses about success and failure of the particular event. Okay, suppose if you are doing an experiment, what is the probability of the particular event success rate or the failure rate in a particular event? Okay, so that is discussed in the binomial distribution. That means this is mainly depend on success and failure of a particular event. Okay, and Poisson's distribution mainly depends on a rare events. If you want to measure the probability of a rare events, then you can use the Poisson's distribution. That means road accidents, okay, floods, the frequency of floods in a particular region. Okay, so these are very rare conditions. Okay, if you want to know the probability of that particular rare conditions, then you will use the Poisson's distribution. Okay, so both are expressed in digital, that means integers. That's why these particular two distributions comes under discrete probability distribution. And continuous probability distribution, we have normal distribution and exponential distribution. So in normal distribution, we are not taking an integer, we are taking the intervals. Okay, in that particular intervals, this particular probability lies. You can't express a single number. You have to take the intervals for expressing the probability of a particular event. So normal distribution and exponential distribution both will give an intervals for occurring of a particular event, probability of occurrence of a particular event. Okay, so first we will discuss about binomial distribution. Okay, suppose if an event E has probability P of occurrence in each and independent trials, then and that of failure in any trial is Q is equal to 1 minus P. P means here probability of success. Q means probability of failure in an individual trials. Okay, so then the probability that it will occur exactly or times in an n trials. Okay, so suppose if you are doing n trials, okay, what is the probability of failure of a particular event in r times? If you want to measure that situation, then you have to go for binomial distribution. So how you measure means f of r is equal to ncr into p of r into q of n minus r. So here there is notations. R means number of successes that results from the binomial distribution. Okay, suppose if you want an event, how many times that event has happened in that particular experiment, that is R. So number of times success in that particular result, binomial result. R is number of success, and n means number of trials in the binomial experiment. So how many times you repeated that particular experiment, that is n, number of trials. And p, probability of success on an individual trial. So individual trial, suppose if had this happened in first trial, okay, if it is happened, p, success. If it is not happened, failure, that means q. Okay, so 10 times, suppose if you are doing this particular experiment 10 times, okay, so in each time, what is the success rate of getting head, that is p. Okay, suppose if you ask 3 times, if that particular in 10 trials, if that particular head is comes under 3 times, okay, so r becomes 3. So that is the difference between R and P. P means you are calculating P on individual trials, and R means you are calculating that value on whole trials. That means 10 times. What is the success rate? P means on individual trial, what is the success rate? Okay, and Q also on individual trial, what is the failure rate? So Q is equal to 1 minus P. NCR is equal to number of combinations of n things taken r at times. Okay, so the problem, a coin is tossed 6 times, that means n is 6. Okay, what is the probability of obtaining 4 or more heads? Okay, so here r is equal to 4, 5, 6. That means 4 or more heads. Okay, so when a toss is that means when a toss is that means coin is tossed 6 times, that means 6 results, 6 trials, right? So what is the probability of success of 4 heads? So it may be 4 times head appears, or 5 times head appears, or 6 times. Okay. So you have to calculate 3 times. R is equal to 4, R is equal to 5, and R is equal to 6. Okay. So when a coin is tossed, the probability of head or tail in case of unbiased coin. Okay. So P is equal to half and Q is equal to half. That means individual trial. Suppose if you tossed a coin, so head appears 1/2. That means chances of head appearance is half, and chances of failure of appearing head is half also, right? So 1/2 and 1/2, P is equal to 1/2, Q is equal to 1/2. Now you have to apply these particular values on the above formula. For first, when 4 heads obtain, the probability of obtaining 4 heads. So NCR into P power R into Q power n minus R. Here n is 6, R is 4, and P is half and Q is half. If you calculate that particular value, then you will get 0.234. And for again, you have to calculate the same procedure for 5 heads, appearing 5 heads. The probability of obtaining 5 heads. Now R is 5, N is 6, R is 5, P is half, and Q is half. You will get 0.094 for 6 heads. That means you toss it that particular coin 6 times, and every time you got the head. So 6 heads. The probability of obtaining 6 heads is n is 6, r is 6, p is half, q is half. You just apply that particular values on ncr into p power r, q power n minus r. You will get 0.016. So you have to add all these particular situations because you want the probability of obtaining 4 or more heads. So for 4, what is the probability? 0.234. For 5, the probability is 0.094. For 6, the probability is 0.016. So if you sum up all these things, then you will get the answer 0.344. So this is the binomial distribution. Okay. So that means binomial distribution mainly focuses on success or failure rate. Okay, if you want to know whether that particular trial, in that particular trial, the event happened successfully or failed to happen that particular event. Okay, so that will be described in binomial distribution. And next one is Poisson's distribution. So as I already told you, Poisson's distribution mainly focuses on rare situations. Okay, that means these particular events happen very rarely. The frequency is very small. Okay, so that type of events. If you want to know the event occurrence, okay, the probability of event occurrence, okay, then you will use Poisson's distribution. Okay, so that's why the Poisson's distribution is called the law of improbability events. Improbability events means you can't expect that will happen. Okay, because these are very rare situations. But still, the statisticians are very interested to observe these type of situations because they want to know the frequency level of that particular events. Okay, so that means floods, serious floods in a particular region, accidents happen in a particular road or highway, or that means radiation from nuclear reactors. Okay, so these type of events happen very rarely, and they want to know the frequency of that particular events happened. Okay, so that they can take the precautionary measures. Okay, so that's why they are calculating this type of events. Okay. So the Poisson's distribution, for the Poisson's distribution, if you want to calculate that particular event's probability, occurrence of that particular events, okay, so P of R is equal to e power minus m into m power r by r factorial. So here r can be 1, 2, 3, 4, etc. Infinity. Okay, you can take any number. E means it is a algorithm, that means logarithm, natural logarithm. E value is 2.7183. Okay, m is the mean of the Poisson's distribution. The formula is np, n into p. P means success rate. Okay, so the average number of occurrence of that particular event. M is the average number of occurrence of that particular event, the mean value. Okay, so you just see the problem. The suppose that a manufactured product has two defects per unit. So two defects per unit means the average defectives in the particular item is 2. So m is equal to 2. Okay, so 2 defective per unit of product inspected. Using Poisson's distribution, calculate the probability of finding a product without any defect, 3 defects or 4 defects. Okay, so already they inspected, they got that for any, for single unit, every single unit they expected 2 defectives. They that means they inspected 2 defects on each and every product. Okay, average 2 defects on each and every product. Now they are expecting 0 defects or 3 defects or 4 defects in a single pieces. So what is the probability? Okay, so now we know the value of m is equal to 2. Okay, so now you apply that particular value on the formula. P of r is equal to e power minus m into m power r by r factorial. So here R means suppose 0 defectives. So R is equal to 0. Okay. So P of 0 is equal to e power minus 2 into 2 power 0 by 0 factorial. So here there is no 0 factorial, means 1. Okay. So 2 power 0 means it is also 1. Okay, so e power minus 2. You have to calculate e power minus 2 into 1 by 1. So e power minus 2 is 0.135. So no any defective. Okay, so without any defective, the probability of occurrence of that type of product means 0.135. Okay, and suppose p of 1 means you can expect one defect on each product. Okay, so p of 1 is equal to, here r is equal to 1. That means e power minus 2 into 2 power 1 by 1 factorial. Actually that is the formula, but here we have already p of 0. P of 0 means e power minus m, right? So e power minus 2 is common for every problem, every formula. Okay, so p power 0 into m. Okay, so that is 0.135 into m means 2, so 0.27. And for two defectives, p of 2, okay, that means two defectives on each and every product. Okay, so the probability, you have to calculate the probability. So p of 1, so P of 1 means e power minus m into m, right? So P of 1 into m by 2, because here you are calculating P of 2 means e power minus 2 into m power r. M power r means 2 power 2 by r factorial, 2 factorial. So that's why you are calculating P of 1 into m by 2. Okay, so P of 1 means e power minus 2 into m. Okay, m square means again it m by 2 is remained in this particular thing. So that's why P of 2 is equal to P of 1 into m by 2. Okay, so 0.27 into 2 by 2 is equal to 0.27. For P of 3 also, that means if you don't want to calculate this particular method, then you just directly apply the formulas on the that means values on the above formula, e power minus m into m power r by r factorial. That means here r is 3, so e power minus m, e power minus 2 into 2 power 3 by 3 factorial. Okay, if you apply that and calculate that particular equation, then you will get 0.18. And p power 4, that means r is equal to 4. So again e power minus 2 into 2 power 4 by 4 factorial. If you calculate that, then you will get 0.09. Okay, so these are the values, but here they only asked without any defect, 3 defects or 4 defects. Without any defect, the probability is p power 0, that means 0.135. So 3 defects means p power 3. P power 3 is 0.18. So 4 defects means p power 4, 0.09. So these are the answers for this particular problem. So this is the Poisson's distribution. And now normal distribution. As I already told you, normal distribution means it is a continuous distribution. You are not taking any specific value, because if you observe in Poisson's distribution, the answers are integers, 0.09. Okay, so these are numbers. Okay, we can expect the exact numbers. In binomial also 0.344, okay, 0.0616. So that means we are expecting the numbers. But in normal distribution, you are that means you are taking the class intervals, confidence levels. Okay, so according to the confidence levels, you are calculating the x bar, that means average, standard deviation, and this particular normal distributions. Okay, so that's why normal distribution is a continuous distribution, probability distribution. And normal distribution is expressed in this particular curve. Okay, so this is the symbol of normal distribution, standard normal distribution. Okay, this is the bell shaped curve, and the middle of center of this particular curve is x bar. Okay, that means average. X bar is always 0 at the center point. Okay, so from the right side you will get the positive values, x bar plus sigma. Sigma means standard deviation. Okay, so from right side you will get the positive results, and for left side you will get the negative results. Okay, that means negative, x bar minus sigma, x bar minus 2 sigma. Okay, that means left side negative values and right side you have a positive values, and center the average is always 0. So this is the properties of normal distribution. Okay, so if you measure the percentage of these particular intervals, that means because center average is 0, but x bar plus sigma and x bar minus sigma, so between this particular gap, what is the percentage? 68.27 percentage. That means the area covered under this particular curve is 68.27%. And x bar plus 2 sigma and x bar minus 2 sigma, the area covered under this particular intervals is 95.45 percentage. And x bar plus 3 sigma and x bar minus 3 sigma, the area covered is 99.73%. These are called confidential confidence limits. Okay, because these intervals comes under confidence. Okay, mainly we discuss anything on a confidence levels. 5% confidence levels means 95, sorry, sigma levels, sorry, significance level. 5% significance levels means 5% you can get the error, and 95% you never get the error. Okay, so that means 95% you are confident on that particular answer or the particular situation, and 5% you may get the error, because we are not in normal distribution or any distribution, the data collection is purely on sample. We are not collecting the data on population. We are not considering total population. We are calculating only sample data. because sample is only representation of population, and we are in that means we are generalizing that particular answers. That's why maybe we are giving some confidence levels. Okay, that means that particular sample which is derived from the population, this generalized results reflect that particular population characteristics on 95% confidence or 99% confidence levels. Okay, so according to the sample size you can take the confidence levels. Suppose if your sample size is large, then you can take 99.73% confidence levels. That means because this particular large sample will represent the characteristics of population very effectively. Okay, so according to the sample size we can take the confidence levels. Okay, so this is the normal distribution chart. Through this particular chart only we will measure the values from this particular curve. Okay, so how we will calculate the normal distribution problems. Okay, so find the area under the normal curve for z is equal to 1.54. Z means it is a symbol of normal distribution. Z is the standard normal distribution symbol. Okay, so z is equal to 1.54. What is the area covered under z is equal to 1.54? Okay, so you just take the bell shaped curve and you just take center point as a 0. Okay, so from center point to positive, because z is equal to 1.54, it is a positive value, you have to take the positive side. Okay, so 0 to 1.54. Okay, so what that means, you just highlight that particular area 0 to 1.54. The area under between these particular values is you have to find out. Okay, so you just go through this particular table and find 1.54 value. That means here on left side we have z to first decimal values, so you just see 1.5 value in this particular left side, 1.5, and we want the value of 1.54, right? Here we have 1.5 and we have to see 0.04 on the top side. Okay, so 1.5 and 0.04, the corresponding value is the area. Okay, so 1.5 and 0.04, the correspondence value is 0.4382 in the table. Okay, if you just see that particular value 0.4382. Okay, it is in um third. Okay, that means third group, first, second, third, fifth column, third group, fifth column, third group, last row, and column is fifth, that is 0.4382, so 1.54. Okay, so that means the area covered under this particular value from 0 to 1.54 is 0.4382. Okay, now another example, because this is a symmetric nature. Okay, so this is a bell shaped and symmetric nature, you don't have a negative values. Suppose if they ask z is equal to minus 1.54, again you have to represent negative side of that particular value, but the value is same because this is symmetric. Okay, so the value from left side and right side, the value is same. Okay, so for negative one minus 1.54 also the area is same, 0.4382. Okay, so suppose if they ask z is equal to minus 1.54, then also the answer is 0.4382. And next problem is find the area right of z is equal to 0.25. So first from the center 0 to, you have to take 0.25. Okay, you just draw a line at 0.25. You want right side of that particular area, right? So you just get the value of 0.25 from the table. Okay, so 0.2 and 0.05. So 0.2, 0.05, the value is 0.0987. 0.0987. Okay, now you just go through this particular value 0 to 0.25. The value is 0.0987. Now you want right side of that particular value. How you will get the right side of that particular value means, because this particular curve, okay, the total curve value is 1. Okay, so the total curve value is 1 means half of the curve value is 0.5 and half of the curve value is 0.5. Okay, that means from the center 0. Okay, the center value is 0. From that particular 0, right side value is 0.5 and left side value is 0.5. Now you just calculate that. Okay, from 0 to 0.25, the area under this particular curve is 0.098, right? So the right side area, you want a right side area, total area of that particular thing 0.5. You just subtract the table value from 0.5. That means 0.5 minus 0.0987. You will get the right side area. Okay, so 0.4013. Okay, so again I am repeating, the curve total value is 1. That means from the center 0 onwards, right side 0.1, left side value is 0.5 and 0.5. Okay, now you have to calculate the values from the 0.5. You have to add the value to the 0.5 or you have to subtract the value from the 0.5. Okay, now see another problem. Find the area to the left of z is equal to 1.96. Okay, so z is equal to 1.96. So it is a positive value. That's why from the center to the right side, okay, you have to represent 1.96. So center, the value is 0. Okay, from the center onwards, you have to mark this particular 1.96 from the right side. Okay, so first calculate the value of 1.96 from the table. Okay, so 1.96. So 1.9.06. Okay, so the value is 0.4750. 0.4750. Okay, so the value from 0 to 1.96, the area under this particular values is 0.4750. Now you want the left side value, right? The left side value is 0.5. As we already discussed, from 0 onwards, right side the total value is 0.5, left side the total value is 0.5. Because you already know from 0 to 1.96, the area value is 0.4750 and the left side value is total left side value is 0.5. You just add these two values, 0.5 plus 0.4750. Then you will get the total area value 0.9750. Okay, so that is the left side area value from z is equal to 1.96. And next, find the area between z is equal to 0.60 and 1.80. Both values are positive values. Then you have to represent on the right side of this particular center 0. Okay, so 0, from 0 onwards, okay, you have to draw one line 0.6 and take another line 1.8. Okay, so you want area between these particular values, right? So first that means get the value of 0.60 from the table. Okay, 0.60. Okay, at the starting 0.6, 0.2257. Okay, that is zero point 0.6 value. and 1.8 value is 0.4641. Okay, so now table value of z is equal to 0.6 is 0.2257, and the table value of 1.8 is 0.4641. Now you want the middle of these particular values, right? So you just subtract both values, then you will get the middle value. Okay, so 0.4641 minus 0.2257, you will get 0.2384. So that is the area between these two values. And next one, find the area between z is equal to minus 0.4 and z is equal to 0.6. That means minus value and positive value. So center there is a 0. From that particular center you have to take left side value as minus 0.4 and positive side value, right side value as 0.6. Okay, so between these values what is the area covered? Okay, again you just go to the table, consider 0.4 value and 0.6 value. Okay, 0.4 means 0.1554 and 0.6 value means 0.2257. Okay, so from the table we got the values 0.1554, 0.2257. Now you want these both values, right? So you just add these both values. Okay, because under these particular values, so one is right side and another one is positive, so you just club these two values, then you will get the area under this particular curve. That means between these particular values 0.1554 and 0.2257 is equal to 0.3811. So this is the area, that means 38.11% of area is lied between minus 0.4 and 0.6. So another problem in normal distribution. Okay, so this type of problems you can expect in your final examinations. Okay, so the income of a group of 10,000 persons was found to be normally distributed. Okay, so 10,000 persons income levels was normally distributed with mean 750 per month and standard deviation 50. Show that uh, show that this group about 95% had income exceeded 668 rupees and only 5% had income exceeded 832. What was the lowest income among the richest 100? Okay, now you have to, because this is normally distributed, you have to use normal distribution method for calculating these particular values. So as we discussed, z is the normal distribution symbol. Now for calculating z value there is a formula, x minus x bar by sigma. Okay, so x is the variable, x bar is the average, and z is standard deviation. Okay, so from the above problem we can get the x bar mean value. Mean value is 750 rupees per month, so x bar is 750, and standard deviation is also given 50 rupees, so sigma is equal to 50. Okay, so for first problem, okay, show that the group about 95% had income exceeded 668 rupees. Okay, so 668 rupees exceeded, so x is 668 rupees. Now you just find out the z value. So z is equal to x minus x bar by sigma. That means 668 minus 750 by 50. Okay. So that is minus 1.64. You just represent minus 1.64 on the normal distribution curve. In the previous problems we discussed z is equal to minus 1.5 or z is equal to 0.6. We discussed all these values, right? So you just take z is equal to minus 1.64, represent that particular value on the normal distribution curve as represented in this particular problem. Okay, so minus 1.64. And you want exceeded because they discussed the income exceeded 668 rupees on, right? So that's why pause right side minus 1.64. They want the area covered right side of 1.64 because exceeded value. They want exceeded value. So they want to know the area covered right side of the minus 1.64. Okay, so first go to that particular table. You just calculate, you just get the 1.64 value. Z is equal to 1.64. So 1.6, 0.04. You will get the value 0.4495. Okay, so Z is equal to minus 1.64 is 0.4495. Now you want the total value, positive value, total positive curve area. Okay, so total positive curve area value is 0.5. As we discussed, from center onwards, right side zero point 0.5 and left side zero point 0.5. So this particular minus 1.64 to 0, the value is 0.4495. But from 0 to positive side, the value is 0.5, right? So to know the total area of this particular thing, you have to add these two values. So 0.4495 plus 0.5. So you will get 0.9495. Okay, so the expected number of persons getting above 668 rupees is because the group of people are 10,000 persons. It is given in the problem. So 10,000 into 0.9495. That means 9,495 people are drawing above 668 rupees salary. Okay, so that is the first problem. And next one, the second problem is they are asking you 5% had income exceeded 832 rupees. So 832 rupees. Here x is equal to 832 rupees. Okay. And x is 832, x bar is 750, sigma is 50. You just apply that particular thing on the formula z is equal to x minus x bar by sigma. Then you will get 1.64. Now you got positive 1.64. Okay, so you just see that particular diagram, second diagram. Okay, so positive side you have to represent that particular value, right side you have to represent that value 1.64. Okay, so here they are asking exceeded 5% had income exceeded 832 rupees. That means right side of that particular region from the 1.64, right side region value they want to find. Okay, so again, you just go to that particular table, calculate the 1.64 as we already calculated that particular value. So 1.64 means 0.4495. Okay, now you have to subtract that particular value from the zero point 0.5 because right side the total curve value is 0.5, but half of the value, that means from 1.64 onwards the value is 0.4495. So the remaining value we don't know. So to find that value you have to subtract from the total area. So total area is zero point 0.5. So zero point 0.5 minus 0.4495 is equal to 0.0505. So you just multiply with 10,000. 10,000 into 0.0505. That means 505. So 5% of people are exceeded or they are drawing 830 above 832 rupees salary. Okay, so that is the second one. And third one, they are asking you what was the lowest income among the richest 100. So here they have given integer 100 people. Okay, 100 people. So Z value. Okay, they are considering the Z value. So here you have, they want to know richest 100. and group of 10,000 people. From the group of 10,000 people, they want to know the lowest income among the richest 100. So 100 by 10,000, you have to get the ratio probability. So 100 by 10,000 is 0.01. Okay, so they want to know the lowest income of that particular richest 100 people. Okay, so that's why you have to know the area covered between this particular 0 to 0.01. Okay, suppose from 0 to 0.1, that is the value of 100 richest people. But remaining value means you don't know the remaining curve value. So how you will get that particular value? 0.5 minus 0.01. So 0.5 minus 0.01 is 0.49. You just see that particular diagram. Till now we have z value. Z is equal to minus 6.4, that value. Now we have area value. It is not z value, it is area covered. Okay, so 0.9, 0.490. Okay, so 0.490, which is corresponded to, that means in the table you have to see in the middle values. You can't see the column and row values. You have to see in the middle what is the value, what is the value corresponded to 0.49. Okay, in the middle values 0.49. Okay, 0.4901, this particular value is corresponded to the 2.33. Okay, so 2.33, this particular 0.4901, that particular value is corresponded to 2.33. Okay, so now, so 0.4900 is corresponded to the table value of 2.33. Now z value is 2.33. Okay, you want to calculate the x value, you have to find out the x value. Okay, so z is 2.33. Okay, x bar is 750 and sigma is 50. You calculate the x value from the above formula. Z is equal to x minus x bar by sigma. So 2.33 is equal to x minus 750 by 50. So you will get x value as 866.5 rupees. That means from the richest 100 people, the richest people, that means the lowest one is earning 866.50 rupees. So this way you have to calculate the normal distribution problems. Okay, in next class we will discuss about sampling and all these things, and today is the last section for quantitative techniques. Do attend the classes. Okay, and today's section is over.
Satyanarayana. Satyanarayana.
Yes, sir. Tell me, sir.
Okay, tomorrow we will meet in the next class.
Sir, once again, I have a small doubt about not a this. I don't have any type of link to pay the examination fees. I don't have any registered number due to my phone problem.
For which?
Actually, I am to
Which
pay the
document?
examination fees, sir. Examination fees.
Examination fee last date is 3rd November.
Yes, sir. Yes, sir. But
You can pay the fee through the link given in the IGNOU website homepage itself.
sir, actually, I tried to pay the link through the link,
Ah,
but there is a showing as the registered number is not correct. Or
what is
registered number.
the number?
Once again, sir. Calling the mobile.
అంటే ఇలా ఏ క్రైటీరియాలో తీసేది ఇమీడియట్ పక్కన కూర్చుని అడుగుతాం తప్పు లేదు అక్కడ అంత ముందు అడ్మినిస్ట్రేషన్ లో రిజిస్టర్ ఉంటుంది సార్
Sir, 2451.
అప్లై చేసుకుంటాం
One second.
నువ్వు విజయవాడ రాస్తే విజయవాడ హైదరాబాద్ నాకు లేకపోతే ఆ రిజిస్టర్ ఎంతో ఉంటుంది ఎవరు ప్రయారిటీ 1 2 3 ఉంటే వాళ్ళకి ఇచ్చారు యూనివర్సిటీ మొదట్లో యూనివర్సిటీ
Number?
2451 455 272.
మొహం చూసి ఎప్పుడైతే అది వచ్చిందో ఈ గొడవ వచ్చిందంటే
Where do you want to write the exam?
అడ్జస్ట్ చేయడం కూడా లేదు.
December, sir.
No. Place of exam center. Visakhapatnam or Rajahmundry?
Rajahmundry, sir. I applied for Rajahmundry only.
Okay. Your enrollment number program is not found.
Yes, sir.
8 years.
Okay. You send one email immediately.
I'm
Please to ask you, sir.
By taking the screenshot, you send one email.
Okay, sir. Thank you. I will send you.
We will do that.
Okay, sir.
Okay.
Okay. Sir, I have another small doubt. Assignments. What is the last date for assignments, sir?
November 30th.
Sir?
November 30th.
November 30th. Assignment submission.
Yes.
Okay. Thank you, sir. Thank you.
Fine.